Now, let's talk about polynomial functions and, again, recognizing some local behavior of their graphs. Okay, so the first is to be able to identify X and Y-intercepts from an equation. And notice I put the equation, and I'll tend to do this in two different forms. I'll put it in a form where it's written as factors, which are often easier to find, especially the X-intercepts. And then I'll put it in a form where you have the expanded form, where it's written in that general form, expanded out. Okay, so if you want to find the Y-intercepts, what you're basically going to do is take whatever the function they give you. The Y-intercepts are, or the Y-intercept of a polynomial is going to be the point. Again, there can only be one point. Okay? And every polynomial is going to have exactly one Y-intercept. And it's the point where x is 0. So if you take your function and you substitute 0 into that function, the corresponding y value, when you evaluate that, is going to be the Y-intercept. So this will give you the Y-intercept of any polynomial. 0, comma, whatever the function is defined as when x is 0. Okay, finding the X-intercepts is going to be a little bit different. Okay, because when you find the X-intercepts, if you're looking at the factored form, you're going to set your factors equal to 0. And those are going to be your X-intercepts, and it'll be in the form 0, comma, or sorry, the x value that makes your factor equal to 0, comma 0. So this will give you your X-intercepts. Okay, and if you're given the expanded form, or the general form, your Y-intercept can still be found the same way. You can still evaluate it in that way, but if it's already expanded out, whatever your constant is, that's going to be your Y-intercept. So notice here in this example, the constant is 0. There's no term written as the constant, and so the Y-intercept for that would be 0, 0. And then the X-intercepts, in order to find what the X-intercepts are, what you will likely do is you can either factor, if you're doing this by hand, and then set the factors equal to 0. Okay, or more than likely, you can just use the solve feature of your TI-89. Okay, so if you use the solve feature, you can find what your X-intercepts are. And so I want you to try these two problems here really quickly. See if you can identify the X-intercepts and Y-intercepts in each of those polynomial forms using those instructions. Walk through the first one you can answer without a calculator, and the second one you'll likely use a calculator. Okay, but when you are setting this up for the first problem, to find the Y-intercept, we know that we're going to plug in a 0 for x. So if I plug in a 0 for each of these x's here, here, and here, I get 0 plus 3 is 3 squared is 9 times 0 plus 1. 9 times 1 is 9. 0 squared minus 6 is negative 6. 9 times negative 6 is negative 54. So my Y-intercept would be 0, negative 54. And make sure that you're writing these as ordered pair when you enter them. Okay, your X-intercepts can be found because they gave you the factors. And what you would do is find the values of x that would make each of these factors equal to 0. So if you set each factor equal to 0, I get x at a negative 3. Here I get x at a negative 1. And here, if you were to take x squared minus 6, set it equal to 0, and solve, add 6 to both sides and extract the square root, I get x is equal to, take into consideration both the positive and negative root. And so you have, these are your 4 different zeros. So I have a negative 3, 0. I have negative 1, 0. I have negative square root 6, 0. And I have square root 6, 0. So it would be a list that contains all those ordered pair. Okay? Again, the order is not going to matter, but you do need to include them as an ordered pair, and you do need to separate each one with a comma. Okay? Now, when I look at the second problem, just because of the nature, it's in this expanded or general form, I look for the constant. There is no constant here, so my y-intercept is just going to be 0. So 0, comma 0. And to find the x-intercepts, rather than factor by hand, what I'm going to do is I'm going to take my equation, set it equal to 0, and solve, and that's going to give me my zeros, my x-intercepts. Okay, so if I use the solve feature, type in my equation, x to the 6th minus 38, x to the 4th plus 72 x squared. And I'm going to set that equal to 0 and solve for x. And when I do, I get my solutions. And so looking at these, I see plus or minus root 2. I see a 6. I see a 0. And I see a negative 6. So I'm going to have 0, 0, which, again, any y-intercept that's the origin is also going to be an x-intercept. Okay, I had plus and minus root 2. So negative root 2, 0, root 2, 0. I had plus or minus 6. So negative 6, 0, and 6, 0. So these are going to be my solutions here. So I think that was all of them.